In this video, I will be showing you how to create a tic-tac-toe game from start to finish using JavaScript, HTML, and CSS. I will also show you how to create the AI using the Minimax algorithm. I expect you to have basic knowledge about HTML, CSS, and JavaScript, but you don't have to know anything too advanced. However, it may take a few rewatches to completely understand the Minimax algorithm. If all you are interested in is the Minimax algorithm, feel free to skip to that section by clicking the link in the description for section 7. To get the most out of this video, you should create the tic-tac-toe game along with me on your own computer. If you get lost while writing the code, you can check out the GitHub repository that goes along with this video. This video has many sections, and there is a folder in the GitHub repo for every section in the video. The folder has what your code should look like at the end of each section. Check out this video's description for links to the code for each section, as well as links to skip ahead to that part of the video. Before we start creating anything, let's make sure your development environment is set up. An easy way to create this project is to use CodePen.io. Just go to the site and then create a new pin. There is a section to put your HTML, your CSS, and your JavaScript. And then everything you create will show up right over here. Also, don't forget to give your pin a name and save it. However, I'm actually going to create the project locally on my machine instead. You can do that with any text editor. I'm using Sublime Text. I'm going to open Sublime Text and then go to File, Open. Now I'm selecting a folder I already created for this project. Inside this project, create 3 files. I use the Sidebar Enhancement Package add-on so I get more options when I right-click here. So we're going to create the 3 files. We're going to create tictactoe.html. Now style.css. And then the last one is going to be script.js. In tictactoe.html, I'm going to paste in basic HTML boilerplate code that should be included in most projects. You can see that in the head there's already a link to style.css. And also at the end of the body there is a link to the script.js JavaScript file. So that's how all these 3 files that we created are connected. The first thing you should do is insert the title. So right inside the title here, I'll put tic-tac-toe. And if you're creating the project in CodePen, you actually don't need any of this code. All of this is automatically included. Now let's start setting up the basic HTML structure. First of all, I want to let you know that, just like any programming project, there are an infinite ways to create a tic-tac-toe game. There's not really a right way to do it, as long as it works. We're going to use a table to create the 9x9 grid needed for the tic-tac-toe board. After we get this code in, we'll add some CSS to make it look more like a traditional tic-tac-toe board. Now press Command-Shift-D to duplicate that 3 times. And we'll just change this to 1, this to 2, and then Command-Shift-D 2 more times. 3, 4, 5, 6, 7, 8. We're also going to need to display who is the winner of the game. So at the bottom we'll add a div with the class of endgame. Also, we'll add a button that will allow the player to reset the game after it ends. While we are putting this at the bottom, later we'll add some CSS to position the in-game message on the top of the tic-tac-toe board. Also, that reset button will eventually go into the in-game element. Next, we'll start working on the CSS. Okay, before we switch over to our CSS file, you can see that I opened up a browser window right here, and it's going to show everything that we've created. Right now, the table, there's nothing in the table, so it doesn't show the table, but we can see the replay button. Also, I did realize I named one of my files incorrectly. This was supposed to be script.js, so I'm going to go right-click and rename. Now, this is with my special add-on here, so not everyone can rename right from in Sublime. So now we have the right name, script.js, not script.css. Okay, we'll go over to our Style tab here. And the first thing we're going to style is the TD element. The TD element, if we go back into our HTML, that's what all the cells in our tic-tac-toe game, all the squares are the TD elements. So we're going to set a border and a height and a width. We'll just stop for a second just to see what that looks like so far. So it's already starting to look like a tic-tac-toe board. Let's put in a few more things. And let's see what that does. I'll save that, refresh the page. And now you can see, well, we did add this cursor pointer, so it looks like you can click each square when you're on it. And you can see it still doesn't look like a tic-tac-toe board exactly, so we're going to add a few more things for the styling. Now I'm going to add some styles to the table element. So that's going to style the whole table element that includes everything else here. So border collapse, that's what is going to make it look more like this. So we don't have the two lines for each cell. Now this is just some stuff for positioning. It's going to make sure it's centered. Position absolute means it's not going to be related to other things on the page. And the left 50% and then margin left negative 155 pixels is just a way to center it. So it's going to move 50% to the left, and if we didn't have the margin left, the edge would be at the center. So if I take that out and then refresh that, you can see the edge is right in the center, but we have to move it back over. So the negative 155 pixels, the whole thing is 310 pixels. 310 divided by 2 is 155, so that's why we go negative 155 pixels left. And the top 50 is just so there'll be some space at the top. Because it's absolute now, it's not related to where this button is, so this button just pops up to the top. Now we want to make this look more like a tic-tac-toe game by removing the edge border all the way around. We're going to use the first child selector. So let's see what this would actually select. Table, tr first child, td. So first we're going to go to the table and then the tr first child. So this is the first child, this is the second child, this is the third child. So we're only selecting the first child, which is basically the whole top row here. And td, which will be every TD element. So for every square in this first row here, we're going to do something. Border top equals 0. Let's save that and refresh that page. You can see now there's not a border on top. So I'm just going to copy this. Scroll down here. Let's copy this. Let's get that more toward the top here so we have more room. Paste here. So now instead of first child, we're going to do last child. Instead of border top, we're going to do border bottom. And then if we just look at what that looks like, we just remove the bottom. Now we're going to just change this up slightly. We're going to cut that and then put it on the end of the TD. So we're going to select every table TR and then just the first child TD. So if we go back here, this is the first child. This is the first child, and this is the first child. Instead of border top, it's going to be border left. And we can see what that's going to look like. And then just the same thing. Instead of first child, last child, and border right. Okay, now it's starting to look like a tic-tac-toe board. Now I'm just going to add some code that's going to style this in-game element. This in-game element is going to look like a little modal that pops on top of the tic-tac-toe board at the end of the game. So let me add code for that. Okay, now I got this whole in-game element. You can see we have it display none because it's not going to display until the end of the game. And actually, just to see what it looks like, let's just remove this display none for a second and see what that's going to look like. See, it's going to just pop on top just like that. And let's put that back. Again, you can change styling any way you want to make it look a little more exciting than what I'm doing. Now we're going to finally get into the JavaScript code. The JavaScript part of this video is broken up into 4 sections. First, we're going to set up some variables and add the ability to click a square and show a mark. Second, we are going to add logic to determine the winner and show the winning combination. Third, we'll create a very basic AI and add the code to notify who the winner is. And finally, and this is the most complicated section, we'll create the logic for an unbeatable AI using the Minimax algorithm. I'll demonstrate how it works with some diagrams. So like I said in this first section, we'll set up some variables. So first we're going to initialize the board. So var orig board means original board, and this is eventually going to be an array that keeps track of what's in each square of the tic-tac-toe board, if it's an X or it's an O or nothing. And now this is how we'll show that the human player is going to be 0, and we'll also have a const of the AI player, which we'll set to X. Now you can create these as anything. It doesn't even have to be X and O, and it'll show up in the boards over there. And now we're going to create an array that's going to show the winning combinations for the tic-tac-toe board. And inside this, each winning combination is going to be an array. So it's an array full of arrays. So we have 0, 1, 2. So each square, this is square 0, this is square 1, and this is square 2. If we have O, O, O across, that would score for tic-tac-toe. And the other 2 ways to win across, 0, 3, 6, this would be 0, 3, 6, so that would be a diagonal win. And now I just put the other winning combinations in there. So cells equals document.querySelectorAll and .cell. And let's zoom out a little bit. So that means the cells variable is going to store a reference to each cell here. Document.querySelectorAll is going to select each element on the page that has the class of cell, which are all these TD elements. And then we're going to have to call a function to start the game, which is just going to be the start game function. And now we have to define the function. So this is what will happen when the game starts. Also, one thing to point out is that, remember, when you click replay, it's also going to run the start game function. So this start game function will run at the beginning, but also whenever you click replay, it will run the start game function. We have the document.querySelector, and we're going to select the in-game element, and we're going to set the style. So we're going to modify the CSS style, specifically the display property. We're going to set the display property to none. Now if we go back into the style, you can see that the display property is already set to none. But remember, this will also happen when you hit the replay button. That will run the start game function. And at the end of the game, the in-game element is not going to be set to display none. It's actually going to be showing up. So when you click replay, it will be set to none again. And now we're going to finally load something into the original board variable that we have up here. We're going to set it to array.from array9.keys. This is just a fancy way right here to make the array be every number from 0 to 9. So it's going to create an array of 9 elements, and it's going to get just the keys for that element, which is 0 through 9, and it's going to create an array from that other array. So just to show you what I'm talking about, I'm just going to console.log that here. So if I save that, I'm going to run this. Now I'll open up the JavaScript console. You'll see we have an array of elements 0 through 8 here. But let's remove this for now. Now, throughout the course of the game, we'll actually be adding X's and O's to this. So whenever we restart the game, we want to remove all the X's and O's from the board. So we're going to do that with a for loop. So we're just going to go through cells.length, and remember cells is this up here. So it's a reference to every cell up here. And we're going to go through every cell up there, and we're going to do 3 things to each cell. So cells I is going to be each item of the cell when it loops through this for loop. We're going to set the inner text to nothing. So there will be nothing in the cell. And we're going to do remove property background color. That's because I already know that when someone wins, we're going to highlight each square that's part of the winning combination in a certain color. And if the game is restarting, we want to remove that background color. So we're back to having no background color. And then one final thing. We're going to add an event listener on the click event, and we're going to call the turn click function. So now every time anybody clicks one of these things, we're going to call the turn click function. And the turn click function is the next thing we're going to define in our program. For now, just so you can see what's going to happen, we're going to do console.log. And actually, inside the turn click function, we're going to pass in something. So I'm just going to call this square. It's just going to pass in the click event. So we're going to console.log square.target.id. So now it's just going to log the ID of whatever square was clicked. So I'm going to save this. I'll refresh this page, and then let's see what happens. I'm going to click. Oh, I'm getting an unexpected token. Let's see what I did wrong there. It says line 28, and oh, I just forgot to put the word function here. So this is supposed to be a function. Let's save that, refresh, and okay. Cannot read property or remove property. It looks like I spelled this wrong. This would be style. So maybe you already noticed while I was typing it in earlier. But this is a good way to troubleshoot your code. Just look in the JavaScript console and it'll give you an idea of what you did wrong. So now let's refresh this. That's why it's good to try things out periodically while you're programming so you can catch things quickly. I'm actually going to clear the console and then refresh so you can see that there's no errors. And now if I click it, oh, 6, because that's the 0, 1, 2, 3, 4, 5, 6. See, I'm going to click there. Click there. Wherever I click, you can see in the console. Here's 0. Here's 8. You can see it appearing down in the console down here. I know it's kind of small, but it's showing the ID of the square that I'm clicking. But we actually don't want it to just console.log every time you click somewhere. So I'm going to delete this here, and we're going to call another function. Inside the turn click, we're going to call the turn function. And we're going to pass in the ID that we're clicking, and we're going to pass in HU player, because it's the human player that's doing the turn. So actually that's the only thing that's going to be in the turn click function is calling the turn function. And the reason why we don't go directly to the turn function is because the turn function can be called with either the human player or the AI player. So if a human is clicking, we're going to call the turn function with the human player and not the AI player. So now let's define the turn function. This time I'll remember to put the word function. The turn function is going to take 2 parameters, the square ID and the player. And you can see that's what we pass in up here, the square ID and the player. This is the human player. And so we're going to set 2 things. So first of all, we're going to set the board array, origBoard, at the ID that we've clicked to player. So on this array, it's going to show the player who just took a turn in that spot. But we don't actually see that array. We're also going to have to update the display so we can see where you just clicked. Okay, document.getElementById. that's going to select an element with the ID. And the square ID, if you remember from the HTML, we have the square IDs here. So we're going to select the element that was just clicked and set the inner text to equal player. So if I save that and refresh, if I click here, wherever I click, you can see an O pops up. So right now we can fill that all up, and then that's all we can do. But let's see if the replay button works. Yeah, we can click replay, and we can keep putting in O's in here. So this is kind of fun for a few seconds, but I think we need some more functionality of our game here. So now we're entering the second part of the JavaScript section, which is actually the fifth part of this video, where I'm going to add logic to determine the winner and show the winning combination. Remember, you can check the link in the description of this video to link to the GitHub repo where you can get the actual code that I'm using. And remember, the folder for each section shows what the code should look like at the end of each section. So if you get the code for the end of section 4, you'll be exactly where I am now. So whenever a turn is taken, we are going to check if the game has been won. So I'm going to add this. Let game 1 equals check win. And check win is going to be another function we're going to define in just a second, but we're going to pass in two things. The original board array, which is an array that shows everything on the board where the X's and O's are, and the player, the current player, because we want to check if a certain player has just won. If game 1, so if we find out that the game has been won, call the game over function with the game 1 variable. You'll see here that this is not just going to be a true or false variable. We're going to have some other information that we'll be passing into the game over function. Okay, now I will define the check win function, which is going to receive the board and the player. The reason why we have to pass in the original board here and we don't just reference the original board variable in this function is because later in this program we will be passing in things that are not the original board, that are different versions of the board than what the current version of the board actually is. You'll understand that when I get to it. Now this line that I'm typing is really just a fancy way to find all the places on the board that have already been played in. Let's bring this down to this line here. So we're going to use the reduce method. The reduce method is going to go through every element of the board array and do something, and it's going to give back one single value. The accumulator is the value that's going to give back at the end, and we're going to initialize the accumulator to an empty array. The E is the element in the board array that we're going through, and the I is the index. So if the element equals the player, then this is a ternary operator, so then we're going to do this. We're going to just concat I. That just means we're going to take the array, the accumulator array, and we're going to add the index to that array. And then if E does not equal player, we're just going to return the accumulator just as it was. So we're not going to add anything to the accumulator. So this is just a way to find every index that the player has played in. And we're going to set game 1 to equal null, and then we're going to check if the game has been won. We're going to do that with a for loop. So this is a for of loop. Actually, this is supposed to be win combos.entries. So remember at the very top, we have the win combos. This is every single thing that could create a win. Every array here could create a win. So we're going to have to loop through every win combo, every possible way that a player can win. So win combos.entries is just a way to get the index and the win. So we're going to have one variable that's 0 because this is index 0. that's going to be the index, and the win, each win that we're looping through, the win is going to be this array with 0, 1, 2. So we're going to need the index of the win. So we need the index and the win in this for of loop. If win.every means we're going to go through every element in the win. So for instance, the first win would just, every element would be 0, 1, 2. So if win.every, so for every element in that, 0, 1, and 2, we're going to check if plays.index of elm is more than -1. So the plays is from up here. Plays is all the places that the player has played on the board. And index of, so we're going to see if the index of the element is more than -1. That's just a fancy way of saying has the player played in every spot that counts as a win for that win. So has the player played in all of these spots? And then it's a loop. Has the player played in all these spots? Has the player played in all these spots? And we go through every single one to see if the players play in all of the spots that constitutes a win combo. If so, that means the player has won. So we're going to set game 1 to equal index player. So now we know which win combo the player won at, and we know which player has won. And now we're just going to break from the function. And after all that, we're going to return game 1. So if nobody wins, game 1 will be null. If someone does win, game 1 will contain which win it was and which player won. So let's go back up here. If game 1, then run game over. If game 1 is null, this will be false. If game 1 contains this here, this will be true, and we'll run the game over function. So now let's define the game over function. And the game over function is going to accept game 1. Our game 1 was defined right up here. And we're going to pass it in here, and it's going to go into here. Inside the game over function, we're going to have 2 for loops. First of all, we want to highlight all the squares that are part of the winning combination. And then we want to make it so the user cannot click any more squares because the game is over. Let index of win combos, and we're going to pass in game1.index. So that was the index of the win combo that was the winner for this game. So we're going to go through every index of that win combo, and we're going to do something. Document.getElementById, the index, that's the index from the win combo, .style.background color. So we're going to set the background color to something. What we set the background color will depend on who just won the game. Game1.player, that's who won the game. If game1.player equals the human player, now this is a ternary operator, we're going to set the background color to blue. If it's the AI player, we're going to set the background color to red. And that's the end of this for loop. Now we're going to have one more for loop. And now we're going to go through every cell, and we're going to make it so you can't click that cell anymore. So we're going to remove the event listener, remove the click event listener, and we have to also pass in what that click event listener was to, the turn click, and set this to false. Okay, so now let's see how this works. We're going to refresh here with all of our new code. Ooh, we have some error here. Missing initializer in destructuring declaration 41. So let's go up there. Oh, I think it's just so we have an extra parentheses here. Let's see if that solves the problem. Now let's clear the console and refresh. Unexpected token 44. So let's see what happened there. And here it looks like here I was missing a parentheses. It should be index of element is less than -1. So let's try that. We're going to refresh this and another error. Okay, let's see what we did here. I don't think we need this parentheses. So let's see if that fixed the problem. I think it just fixed the problem. So let's try this out. Okay, if we put 3 in a row, it turns to blue. And we can't click anywhere. Let's replay. Now we should be able to click 3 in a row, turns to blue, and we can't click anywhere. Turns to blue, we can't click anywhere. So, that works. We can now determine a winner. Next up, we're going to create a basic AI and show the winner box. Well, I hope you're still following along and creating your own program along with my program. We've just started section 6, so if you get the code from the GitHub repository that shows the end of section 5, you should be caught up with where I'm at now. Again, just check the link in the description for that code. Right now there's no AI, so the computer doesn't even do anything when you play. You're just only putting O's in there. So we're going to change that in this section. This will just be a basic AI without the Minimax algorithm. In the next section, we're going to implement the Minimax algorithm. So let's go back up to the turn click function. So when the turn click function is run, the human player is going to take a turn, but right after the human player takes a turn, the AI player will take a turn. So before the AI player takes a turn, we're going to check if it's a tie. So if it's a tie game, that means every square is full and nobody has won yet. So if every square is full, the computer player is not going to take a turn. So if there's not a tie, then the computer player will take a turn. Turn, best spot, AI player. So just up here, we put in the target ID that was clicked. Here we're going to get the ID based on this other function. The best spot function is going to return the ID to click. And instead of the human player, we have the AI player taking the turn. Let's do one last thing while we're in this function. Right now you can click on a place that's already been clicked. So we want to make it so you cannot click on a place that's already been clicked. So let's add that logic right up here. If type of origboard square.target.id equals number. So if you remember, the original board array gets filled with the numbers 0 through 9. And then when a turn is taken, that index will be replaced not with a number anymore, but with the X or the O, the human player or the AI player. So if the type of the ID that was just clicked is a number, that means that neither the human nor the AI player has played in that spot. So if nobody has played in that spot, then let's cut those out, put it right here. Then we'll do this, we'll run the turns here. So the human player and then the computer player right there. So you can see we made two functions, check tie and best spot. So let's create those functions. Let's go down to the bottom here and we'll start with the best spot function. Now this is how we're going to find the spot for the AI player to play. Remember I said that eventually we'll make it more complicated, but this time we're just going to make something really simple. So the best spot function is just going to run a different function we still have to create that's going to find all of the empty squares and just get the first element from the empty squares. So it's just always going to play in the first empty squares. So before we create the check tie function, let's finish creating the empty squares function. I'll put it right up here. So function empty squares. So we're going to filter every element in the original board to see if the type of the element equals a number. If the type of is a number, we're going to return that. So all the squares that are a number are empty, and the squares that are an X or an O are not empty. And the best spot is just going to find the first square that's not empty. So now, like I said, we're going to have the check tie function. So to check if it's a tie, we just use the empty squares function that we just created. If the length equals 0, that means every square is filled up and nobody's won yet, because normally every time someone plays a turn, it checks to see if someone's won. So if every square is filled up and nobody is won, that means there's a tie. We're going to do a few things inside a for loop, because we're going to do something to every single cell in the tic-tac-toe board. So we're going to set the background color of every cell to green. And we're going to remove the event listener so the user can't click anywhere right now, because the game's over. And we're going to declare a winner. This is actually a function we still have to create. Declare winner. Tie game. That's what we're going to pass in, the words tie game. And return true, because true, it's a true that it's a tie. Or if this if statement is false, we're going to return false. Okay, we just created a new function, so now we have to define that function, declare winner. Let's put that one right up here. Declare winner. Oh, and we've passed in who. Right down here, we passed in tie game, but we'll also sometimes pass in if the computer wins or if the human wins. So inside this function, we're going to do something. So we're finally going to show the in-game section. It was set, the style was set to display none, but now it's going to be set to display block. I'm just going to duplicate this line. I'm going to select .ingame.text. So now if we go back into the HTML, the .text is here. So the inside in-game and then inside text we're going to set the inner text to who. That's what we passed in here. So if it's a tie game, it's going to say tie game. So we also wanted to say if you win or you lose. So let's go over to game over up here. And when there's a game over, we're going to also call the declare winner function. And we're going to have a ternary operator to see what we're going to pass into the declare winner function. So if the game1.player is a human player, we're going to pass in the words you win. Else, we're going to pass in the words you lose. So I think we're done implementing this basic AI so you can actually play a full game of tic-tac-toe. Let's save it and test and see if we get any errors. Ooh, no errors so far. Let's see. Yep. So I played here. The computer automatically played on the next open spot. The computer played on the next open spot. And it says, you win. So let's replay. Now let's see if I can get the computer to win. You lose. Now let's see if we can get a tie game. Tie game. So we just saw every end state. You win, you lose, and tie game. At this point, you have a fully functional tic-tac-toe game. However, as you can see, it's pretty easy to beat. Now we will create an unbeatable AI using the Minimax algorithm. After we implement the Minimax algorithm, you will never see the message, you win, on the screen. Much of this section on the Minimax algorithm is taken by a great article by Ahmed Abdulsaheb on the topic. I have linked to the article in the description of this video. I definitely recommend you check it out. A minimax algorithm can best be defined as a recursive function that does the following things. 1. Returns a value if a terminal state is found, in this case, positive 10, 0, and negative 10. 2. Go through available spots on the board. 3. Call the minimax function on each available spot, a recursion. 4. Evaluate returning values from function calls. And 5. Return the best value. I'm going to go through the code for the minimax function. Don't worry if you don't completely understand it at first. After I show the code, I'm going to use an example and diagram to demonstrate the algorithm's function calls one by one. Also, if you're anything like me, you may want to watch this section more than once to get a grasp on it. Before we define the minimax function, we'll change the best spot function. It's actually just going to return the result of calling the minimax function. It's going to call the minimax function, passing in orig board and AI player because it's the AI player playing, and it's going to get .index because the result of the minimax function is an object, and .index will be the index that the computer should play in. So we'll define the minimax function with two arguments, new board and player. Then we need to find the indexes of the available spots in the board using the empty squares function and set them to a square called availSpots. We'll check for terminal states, meaning someone winning, and return a value accordingly. If 0 wins, you should return negative 10. If x wins, you should return positive 10. In addition, if the length of the available spots array is 0, that means there is no more room to play. The game has resulted in a tie, and you should return 0. Next, you need to collect the scores from each of the empty spots to evaluate later. Therefore, make an array called moves and loop through empty spots while collecting each move's index and score in an object called move. Then set the index number of the empty spot that was stored as a number in the orig board to the index property of the move object. Then set the empty spot on the new board to the current player and call the minimax function with the other player and the newly changed new board. Next, you should store the object resulted from the minimax function call that includes a score property to the score property of the move object. If the minimax function does not find a terminal state, it keeps recursively going level by level deeper into the game. This recursion happens until it reaches a terminal state and returns a score one level up. Finally, Minimax resets new board to what it was before and pushes the move object to the moves array. Then the Minimax algorithm needs to evaluate the best move in the moves array. It should choose the move with the highest score when AI is playing, and the move with the lowest score when the human is playing. Therefore, if the player is AI player, it sets a variable called best score to a very low number and loops through the moves array. If a move has a higher score than best score, the algorithm stores that move. In case there are moves with similar score, only the first one will be stored. The same evaluation process happens when player is Hugh player. But this time, best score would be set to a high number, and Minimax looks for a move with the lowest score to store. At the end, Minimax returns the object stored in best move. I want to emphasize again that it's okay if it takes a few reviews to understand this. I had to go over it multiple times when I first learned it, but this next example should help. Before we go over the example, let's actually just try this out just to make sure I didn't make any mistakes when I was creating the code. So we're going to save that, refresh over here, and let's see. Ooh, reference error, origin board not defined, JavaScript 76. So let's go up to 76 up here, and there should be an I in there. Okay, let's save that, refresh, and let's see if we have any more errors. And this seems to be working. Let's see if it's possible to win. If it's not possible to win, then I did something right. Okay, I'm going to try it out a little more later, but let's go over to the example. In this example, we're starting with this board configuration and then following how the Minimax algorithm determines the next move. Assume the AI is X and the human player is O. I'm going to use this figure right here to follow the algorithm's function calls one by one. Remember, in this example, we're pretending we're at the end of a tic-tac-toe game, so there's just one more move left. So the board looks like this. So we're going to go through the code to figure out the exact logic that the program takes to figure out where to play. So in figure 1, we're at the very beginning of the Minimax algorithm, and the orig board and the AI player is fed into the algorithm. And the algorithm is going to make a list of the 3 empty spots that it finds. So if you see right here, we have the spot here, here, the middle, and then the bottom left. It's going to check for terminal states and then loop through every empty spot starting from the first one. Here, it's going to change the new board by placing the AI player in the first empty spot. After that, it's going to call itself with new board and the human player and wait for the function call to return a value. So we're just on the first function call. We're not to the end of the first function call yet, but now we're already going to the second function call. So while the first function call is still running, the second one starts by making a list of the 2 empty spots it finds, just these 2. That's here where it's making a list of the 2 empty spots. It's going to check for terminal states and then loop through the empty spot starting at the first one. Then it changes the new board by placing the human player in the first empty spot. After that, it calls itself with new board and the AI player and waits for the function call to return a value. We're at the third function call, which is right here. Still, function call 2 and 1 have not finished. The algorithm makes a list of empty spots, and this time it's going to find a win. The human player is going to win, therefore it returns an object with the score property and value of -10. And since this second function call up here listed 2 empty spots, the Minimax changes the new board by placing the human player in the second empty spot. So it'll be right here. And then it calls itself with the new port in the AI player. So from function 2, we got to function 3 by placing a spot here in the middle. And then we go from function 2 to function 4 by placing a spot on the bottom left. The algorithm just makes a list of empty spots. The algorithm just makes a list of empty spots and finds a win for the human player after checking for terminal states. And then it's going to return -10 again. On the second function call, the algorithm collects the values coming from lower levels, the third and the fourth function calls. Since the human player's turn resulted in the 2 values, the algorithm chooses the lowest of the 2 values. On the second function call, the algorithm collects the values coming from the lower levels. So we already had the index, and then we're going to assign the score here, and we're going to assign the index to the new board, and then we're pushing all the moves onto the moves array. So that's how all the values have been collected from the third and fourth function calls. Since the human player's turn resulted in the 2 values, the algorithm chooses the lowest of the 2 values. So here's if the player is the AI player, else, which is what we're at now because the player is a human player, it's going to run this code to select the lowest of the values. Since both values are similar, it chooses the first one and returns it up to the first function call. That's down here when it returns moves best move. At this point, the first function call has evaluated the score of moving the AI player in the first empty spot. Next, it changes the new board by placing AI player in the second empty spot. So this was the first empty spot. Here's the second one in the middle. It's going to call itself with the new board and the human player. And I'm going to skip through some of this, of every single thing that happens, but you can see in function call 1 there are 3 empty spots, and that's why there are 3 in level 1. So the first empty spot is function call 2, the second empty spot is function call 5, and the third empty spot is function call 6. 2 empty spots here, 2 moves here. And here, since we found a terminal state, you don't actually go any further, and here there's 2 empty spots, so we try these 2. And then eventually you get down to 8, And because of the recursive nature, and like I was showing before, this gets passed up to the top. Now, toward the end of running the algorithm, the 3 branches of the first function call have all been evaluated. We got the -10, the 10, and the -10. But because the AI player's turn resulted in those values, the algorithm returns an object containing the highest score, which is the +10 at index 4, which is the middle index. So in this scenario, the Minimax concludes that moving the X to the middle of the board results in the best outcome. Now, to speed things along, I didn't explain every single function call, but if you check the article that I linked to in the description, it goes into even more detail about this. I hope with my explanation and just being able to play with the code a little bit, you'll be able to understand the logic behind the Minimax algorithm. Okay, and there's one final thing I still need to do. You can see that the replay button is right up here in the corner, and we want to put it in the pop-up box. So I'm just going to go over to the HTML file, and I'm going to select this button, and then at least on a Mac it's Control Command up. So it's going to move that line up, and then just going to tab it over, and that should put the button in the right spot. So let's refresh here. And now the replay button doesn't show up until the game is over. And you can click the replay button right on that little pop-up. And you now have an unbeatable tic-tac-toe game. There are many ways this game can be improved. So for extra practice, you can think about other features you can implement. For instance, maybe you want to make it 2-player, so there can be 2 human players instead of a human and a computer player. Well, thanks for watching. My name is Bo Carnes. Don't forget to subscribe, and remember, use your code for good.